Hi, welcome to the Dynamics tutorials. Now we're looking at polar coordinates and also with kinetics. So again, still just studying the motion of particles. So we have a curve here that's the spiral r is equal to 4 times theta, where theta is the angle in radians. And then at theta is equal to pi over 3 radians, we're given the theta dot is 2 radians per second, so it's not to say that it's constant, it's just what it is at that one theta location. And then the second derivative of theta with respect to time, theta double dot, is 0.5 radians per second squared. So for our problem statement, we need to find the magnitude of the velocity and the magnitude of the acceleration at that instant. These problems can look very intimidating, but they're actually a little bit easier than the normal and tangential problems typically. When you see these, just go ahead and put together this table. So get the value of r, r dot, r double dot, theta, theta dot, and theta double dot, and fill this table in first. So let's take a look at this. So we've got r is equal to 4 theta, theta is pi thirds. So we plug it in and we get our value for r. For r dot, we have to take a derivative not with respect to theta, but with respect to time. So this is 4 times theta, so we're going to get 4 times theta dot, or d theta dt. Plug in that value for theta dot over there. We get our value for r dot. For r double dot, we take our derivative here, so the second derivative with respect to time would give us our d squared theta dt squared, or theta double dot. Plug in our theta double dot there and get that value. And then down here, it's just a matter of just writing the values down again. So pi over 3, just plug it in the calculator, get that approximate value. And then our theta dot was 2 radians per second, theta double dot was 0.5 radians per second squared. Then here it's just a matter of plugging them into the formula. So take a look at the formulas from the notes or from the book. But you have VR as just r dot. So just plug that in, you get the 8 meters per second squared. V theta, so theta direction velocity, is r times theta dot, r times theta dot here, and get that for v theta. And then for the magnitude of the velocity, it's just these two components squared, added together, and then take a square root. For the acceleration, it's just kind of more of the same. Your formula for the radial component of the acceleration is r double dot minus r times theta dot, that quantity squared. And so you plug in your values, you get a negative 14.76 meters per second squared. And then for a theta, the transverse or theta component of the acceleration, it's equal to r theta double dot plus 2 r dot theta dot. And again, just plug in your values. You get 34.09 meters per second squared. And then square each of those, add them together, take a square root of the result, and you get 37.2 meters per second squared. So it's a lot of calculations with these, but again, if you take this approach of just fill in this table, r, r dot, r double dot, theta, theta dot, theta double dot, once you've got all those values, you really just plug them into the formulas in at that point. Thanks for watching.